Good afternoon, everyone. Welcome to Ray Summit 2024. So let's talk about the future of AI. The future of AI is a sovereign superintelligence. What do I mean by sovereign? It's an AI that can generate its own income, can pay for its own compute, and follows the directives of a decentralized, autonomous organization. I'm Heather Khan. I'm VP of Engineering at O, and I'm joined by my colleague Zach, who's head of AI ML Ops at O. And together we're here to show you the path towards superintelligence and what we've created at O. So let's talk about our mission. Our mission is simple, but it's really ambitious. It's to develop and deploy the world's first sovereign superintelligence. We're building the foundation for that superintelligence. And today I'll talk about the building blocks. But first, what are the challenges in the current industry? Accuracy. Large language models are prone to hallucinations and bias. Speed. These models have hundreds of billions of parameters, up to trillions. It takes a fair amount of time to run inference on these models. Cost. It takes thousands of GPUs and days to months to train these models. And usually in a commercial setting, you have to pick 2 out of 3 factors. We've created O Routing Intelligence, ORI, and we aim to address these 3 challenges for the industry. I want to bring on board Zach. He'll be talking you through the technical details, and then I'll circle back.
Yeah, thanks, Heather. So I'm going to take off the technical part of the talk. So just want to introducing our ORI, which is O Routing Intelligence. And so we have a couple kind of core features we are going to walk you through, and in terms of how we're going to build this architecture of the software. And so first, we've been thinking about a more intelligent way, like to handle the query routing for the AI models. And the second is the multi-agent flow, because we kind of been observing the current, a lot of people are doing the same thing right now, but how we going to do this differently. And third is the Inference Awareness, which is a unique layer we're going to put on top of our system in terms of how we handle different requirement of the inference in terms of the cost, inference speed, token per second, context length, and security as well. And because we request a lot of the kind of stuff going to our systems to support to make this routing intelligence work, and we need to kind of redefine the AI infrastructure a bit more, which I'm going to walk you through some details later. So this is pretty much our core feature at the moment. First, similar to chain of thought, which is everyone's doing this now, and is we going to break down the query, so something we call Cury Decomposition or chain of atomic queries. And so this type of query is a smaller user query, and it's similar to chain of thought, but I'm going to show you a diagram later on. And then a benchmark matching engine, and this is how we want to manage our routing intelligence. We can route it to the benchmark, the top model from our open source LLM benchmark from Hugging Face. And the third is the model agent routing. So just know that we don't not only doing like agent to agent routing, but we also do model to agent, model to model, agent to model as well. And then the last layer is also pretty important and critical. It's for our evaluation and ethical assessment. because we want to build our system, so the responses our AI to give people will be responsibly. So this is first is a Cury decomposition, what we are thinking to do. Similar to chain of thought again, but the bottleneck of chain of thought is normally you would do this sequentially, which means you use the same model to ask, so the model will ask itself and to just repeat this question like chain of thought, like on chain. What we're doing here is a bit different, but we use have the expert LLM to break down each query into a smaller piece. And then for each question, we use a different model to answer those questions. And then some of the query can be done in parallel. So it's more like a partial sequential, partial parallel kind of a process going on here. And yeah, so like I said before, we have the expert model to handle that and then to design the whole chain of atomic query. And then each layer so the first layer, we're going to enforce some ethical filter. So if any question is not aligned with our ethical alignment, and then it won't be answered, for example. And then so you can see like I don't know if the text is big enough for you to see, but for each query, traditionally you have the single LLM to handle everything. But in our vision is we want to route this smaller query to the best model to answer that. And so those best model will be defined by the OpenLLM benchmark. So we pretty much categorize some task, and then we route it to the top model in that benchmark and to answer the question. So we're going to show you some example. And so another thing I would try to do this differently is the evaluation layer. So for each query, we have the response, and then we need to go through a series of kind of evaluation layer. And then we will ensure that it will have the best quality of the output for each model. And then not only that, if the first run, it didn't give a high quality enough response to the user, and then we're going to rerun it. So it's an iteration for each smaller query. And then so this way we can ensure every single kind of response for the smaller query, and it can be answered, it can provide the best quality of the responses. And then so this kind of addresses the current challenges of the agent system, because it's really hard to control the quality of each response because it's a non-deterministic process. So this way we want to turn the non-deterministic process into deterministic, which we can ensure the quality. And this is our benchmark matching engine, which you can see we have a little kind of the table here. And then once you got a query, and then we have the matching model to route it to the right, the LLM to answer the question. And in this case, we have a 32B model here. But what we're doing kind of behind the scene is we have the benchmark registry, which we list all the benchmark, current kind of popular benchmark in our database. And then for each model, we know that, for each benchmark, for example, BBH, you got a pretty good code generation benchmark. And then if you ask the code generation question, and we know, for example, CoLlama 34B, assume it's the best model on the leaderboard right now, and we're going to route that question to this CoLlama 34B model to answer that question. So it just really depends on the question you ask, and then we classify them into a different task category, and then from the task category, we match the right benchmark, and from the benchmark, we pick the best performing model. And we want to do this in a way like in real time, because as you all know, Hugging Face Open LLM leaderboard, the leaderboard will be updated maybe every other hour, because people try to compete and to use their open source model to get the highest rank in the benchmark. So we want to capture that in real time. And so in our backend infrastructure system, and so we set up in a way, and it can be pretty much detect if there's a new changes in the benchmark, and we update our backend LLM inference endpoint. So we will ensure that all the top 5 models in the benchmark, it will be available for our routing intelligence to work. And this is kind of uniqueness of what we do here is also, it's called Inference Awareness. So user can define what kind of requirement that they have in terms of the inference. Maybe they are thinking about to save the cost, so we can route them to a cheaper model to answer that question. If they prefer the faster inference, and then because we have all the data like being updated real time in our database, so we just route it based on users' requirement. So our system can be flexible as well. And so something unique in this approach is we also kind of consider the security compliance. So if you request the model responses you want to generate by the infrastructure complying with your security requirements, such as SAX2 or HIPAA, and then because we have all this metadata, and then so we know, okay, so this model endpoint is coming from this infrastructure, like has this security compliance. So this model would meet users' requirements, so we're going to route the model through that as well. And then this another kind of our thought around the agentic workflow is in our mind. We've been thinking about this is the multi-agent collaboration, right? But it's not we don't want to narrow it down only to the LLM, but eventually we want to have the LLM agent. It will have access to all the open source model, classical ML model, neural network model, computer vision, NLP, time series model, so anything. So we want to have the agent has the capability to actually fine-tune a trend ML model to make some prediction. So that's our kind of end goal is to have this dynamic system. You have the agent perform some ML model prediction on behalf of the ML engineer. And so this could be more powerful in a way. It's not only focused on the LLM, but will be every kind of ML model and also any kind of data processing. And the agent will be able to use different tool or the API, like do function calling and everything, because this is a RAID conference, we're going to talk a little bit about how we set up our infrastructure. So right now we've been in collaboration with IO.net. We utilize their RAID cluster in our infrastructure. And so we have a couple H100 clusters. And to serve our LLM, so we use RAID serve plus vLLM to serve all our LLM's inference for the routing intelligence system. And for the inference registry, we use the benchmark matching engine to handle that, and then we use RAID data because we do fine-tune our model. So eventually we're going to fine-tune the most routed model, and so that fine-tuned model can also serve that purpose. So I have RAID data and RAID trend just to use a different technique to do our fine-tuning. So this is current. We only have a really simple infrastructure at the moment, but we're going to develop a lot of kind of ML ops there within that, and then so we can automatically kind of provide the inference endpoint update and to update our inference registry benchmark database as well. So while we are developing this system, we actually have some unique insight we want to share. So the ORI approach, we aim to solve the multi-agent bottleneck in a way like we have unique awareness in cost, security, latency as well. And so one of the advantage we want to address, I think Heather would mention this later, is because you can see the bottleneck is the inference speed. The inference is not fast enough for you to collaborate for the multi-agent collaboration, because this agent need to wait a long time for another agent to perform the same thing. Another task. So the agent right now is kind of waiting for each other. So the inference is the bottleneck. And then we're going to announce kind of our collaboration. So how we can get a really high speed inference, maybe 10, 20 times faster inference. And so our end goal, for this routing intelligence, in our vision, is more like a new operating system. Pretty much that routing intelligence control everything in your system and can perform on your behalf. I know it's still a bit of a road ahead, like we need to achieve this, but yeah, this is our vision, and we aim to build this within our engineering organization. Here, I'm going to show you maybe some initial results of our benchmark matching engine. And so we only use open source model here. So I know some competitor in the market right now, they doing something similar to the routing mechanism, but a lot of people kind of compare they use some of the closed source model and try to beat the benchmark, but we all use open source here. And so we have a complete couple kind of evaluation for different benchmark. For example, MMLU, MUSR, ARC, all those kind of benchmark, our ROI will be able to outperform a single 70B model. And because we route each question to different model to answer that. And we also have a small demo that we can show you real quick. So this is just still work in progress. We still building out the system, but just in this short demo, just want to show you how kind of each question will be answered by a different model, like it can save the cost and so forth. Yeah, let me see if we can make this work. Okay, so let me refresh. And then I prepared some question. I just don't want to waste your time because my typing with the code might be faster than I type in English. So I just copy the question I prepared and paste here so I can show you how this work. And then, yeah, depending on the internet, I think internet speed here is fine. So right now I asked a coding question, and it's supposed to route me to Llama and to answer this question. You can see like we have the answer speed out to help me, to write this Python script. So you can see in the end, it should show you it's answered by this, I can't really see here, but Llama, right. And then we can try another kind of query and to show you. So this question is more, oops, for the creative writing. And then, yeah, it just, for something will happen next month. But I just want to see if this work. And then because this is creative writing, so it's not supposed to route you to like Llama to answer the question. So actually it get to another model to answer the question. Yeah, I believe this model ranked pretty high in the content generation category. And then we have another one, maybe the entity extraction. So, oops, this is the entity, the extraction question. Yeah, okay, I think it extract the entity right. And this is using another open source model, which I'm not able to see here. It's too small for me to see from the stage. Yeah, maybe the last one, just do that for fun. This is the fact checked question. Just refresh just in case. Yeah, I think it answered this all right, and with another top rank model in the benchmark. Right. So the purpose of showing this demo is just we still like work in progress, but we will have some MVP release pretty soon in a few weeks, and then we will announce soon from our website. Yeah. So we just want to open this up for people to try out as well. Okay.
All right. Yeah, thank you, Zach, for doing the demo. It's amazing what the team has accomplished in just a matter of a few months. So I want to really thank the AI team and our research team at O for putting this together. So let's talk about partnerships next. Cerebras. If you guys are familiar with Cerebras, they're the world's first company that's built a wafer scale engine chip. It's a 10-inch by 10-inch massive behemoth of a chip. And what you can do with it is you can run large language models, massive models, at dramatically reduced inference and training time. We're talking days of months of training reduced to days. And we're poised to become potentially one of their largest customers. Secondly, IO.net. IO.net is a massive decentralized GPU compute platform. They have clusters distributed across the globe. And we want our team of distributed remote engineers to experiment and train on different model architectures at dramatically reduced cost and latency. So how can you guys help? We're not a normal AI company. We don't want to silo everything into a single corporation. We want it decentralized. We want it autonomous. And we need your help. So this is a call to action. Visit O.XYZ. If you're a developer and you want to contribute to open source, take a look at O.XYZ. Contact us. If you're an entrepreneur or investor, get in touch with us. And if you got any more questions, I'll be around Ray Conference, so just feel free to come up to me, ask me any questions. I'm happy to answer. Thank you, guys.